What about this one? What about one like this? Okay, it's going to ask you to graph this transformed function. Okay. So in this case, does everybody agree? Let me take a picture of this real quick. Okay, does everybody agree this is my transformed function? But what did I start with? What's my parent function? If I get rid of all the numbers except the squared, I can't get rid of the 2 because that's in the exponent, right? That's what makes this a quadratic, is that it's an x squared. But if I get rid of all the other numbers, what basic function am I starting with here? The previous examples, it was an absolute value of x. What is it here? Okay, quadratic, good. So it's quadratic or x squared, isn't it? So my parent function is just x squared. Good. So if I'm going to tweak an x squared graph with an a, h, and a k, we know that, oh boy, what happened there? That's not so good. We know that we'll call it h of x. That's what we're using this time. If I want to plug in an a, h, and a k, remember that the a is always what's getting multiplied out front by the function, right? And then h is what's being subtracted from x inside the squared function. So the h would have to go there, right? It'd have to go in parentheses this time because the whole thing is being squared. And the k is the number that's being added outside the function. So what are the values then of a, h, and k? In this example, what's the value of a? Everybody type it in chat for me real quick. Okay, good. It's 4, isn't it? 4 is the number that's being multiplied by the x squared parent graph. Okay. Let's do k. Is there a number that's being added outside of the x squared parent graph? What's k? Okay, good. K is -3. Good. What about h? Is there a number that's being subtracted from h inside of the x squared parent graph, parent function? No, there's not. So what's h? Ah, good. So the value of h is 0, isn't it? Good. Okay. So think what that tells us. It's the same kind of thing we just did in those previous examples, right? H is 0 means we're not horizontally doing anything, right? K is -3. Just like before, we're going down by 3. And A equals 4 means that we're going to be multiplying the parent heights by 4. Okay, so let's use the technology that's given to us in MathXL. This is pretty good technology for practicing this stuff, I think. Let's do this problem. Okay, so there's the values. Now all we've got to do is graph a parabola with those values. Oops, I got to, oh, darn it anyway. Okay, so this changed it very slightly, didn't it? So k is just -1 now instead. So let me make that quick little change. And let's practice using this technology. These are, I think it's kind of fun to use this stuff. So I'm going to click on, there we go. Okay. So notice that for this, there's 2 different kinds of technology problems for graphing that you're going to get. One of them looks like this, where you just choose the kind of function. So we're going to choose a parabola, right? Because this is an x squared graph. Remember the parent graph for a parabola. Let's review that real quick. What does the parent graph for a parabola look like? Okay, if I've got the parent function, we'll call it f of x equals x squared. That's my parabola, right? This is the one where if I go okay, let's go by ones here. How about there? Okay, so look what happens here. If I go, the vertex starts off, you know, in this case it's at 0, 0, right? If I go 1 to the right, how much am I going up? 1, right? If I go 2 to the right, I'm going to go up by 2 squared, right? I'm going to go up by 4, aren't I? Everybody agree? If I go 1 to the right, I go up by 1 squared. If I go up by, sorry, if I go 3 to the right, I'm going to go up by 3 squared. I go up by 9. Everybody agree? That's the shape of my vanilla x squared graph, right? 1 to the right, up 1 squared, 2 to the right, up 2 squared, 3 to the right, up 3 squared, right? Okay. So now when I put this parabola on here, look what it's asking. It wants me to put in this, to type in this information. Okay, what is the horizontal shift? Let's do that part first. It's 0, right? We didn't shift horizontally. What's my vertical shift? My vertical shift is k, that's -1. Okay, look what that does. It drops it down by 1. What's my vertical stretch this time? We're not going to ever do anything with the horizontal stretch. You guys can leave that as 1. What's the vertical stretch going to be? What number am I going to put in there? Whose job is it to stretch vertically, A, H, or K? It's A, isn't it? Right? So my vertical stretch is 4. Right? Okay, let's look at this thing here. Can I zoom in on that? I guess I can't really, can I? Does that seem to do what it's supposed to do? Yeah, it does. Look, from the vertex, if I go 1 to the right, instead of going up 1, I'm going up 1 times 4. I'm going up 4, aren't I? If I go 2 to the right, instead of going up 4, I'm going up 16. I go all the way up to there, right? Clear over there somewhere if I go 2 to the right. Everybody see that? It stretched it out like it was supposed to. Okay, and there's my answer. Everybody see that? So that's one kind where you're just going to type in what are the values for the vertical stretch, the horizontal translation, the vertical translation. That's one of the kinds of problems you're going to be asked to do. Another one, let's get another one here, is like something like this. Okay, let's do one like that. And then after this, I'm going to let you guys work. Okay, so there's the function we're graphing. Look at this for a second, and I want you guys to identify the values of AH and K for me. Because if we can do that, we can graph this thing. That's it. Knowing AH and K is just about as good as knowing what the graph looks like. It's just a matter of plotting some points to get the graph then. So type in chat, what's the value of A? Oh, good. I got them all there. Good. So we got A is 3. Good. We could fill that in. What about H? Be careful with H. What's H? Four. Very good. What's K? -6. All right. So then if we look at this on, let's graph this once, just like we're graphing it on graph paper, and then we'll graph it with technology. Okay, so instead of my vertex starting at the origin, I'm going to have to translate the vertex to where? Horizontally, how far in what direction? So horizontally, what am I doing? Type it in chat. Quick. Right 4. Okay, good. Vertically, I'm doing what? So I'm going right by 4. Vertically, okay, I'm seeing it. I'm going down 6. Okay, so there's going to be my vertex. Okay, now normally I would go 1 to the right and up 1 squared, which is 1, right? I'd go 2 to the right and up 2 squared, which is 4. That would be my normal parent graph shape. Agreed? But we've got to stretch that because A is equal to 3, right? So instead of going right by 1 and up by 1, we're going to go up by 1 times 3, which is 3. So over 1 and up 3. So mine's going to be a lot taller, right? My graph's going to look like it's going to be taller and skinnier. It's going to get stretched so the heights are all 3 times as big. Everybody buy that? Okay. So let's do that with technology then. So here's the other kind of technology. Okay, so the way we do it, oh, this is the same one. Darn it anyway. Okay, I'm just going to go ahead and even though this doesn't match, even though this doesn't match our answer, okay, we'll just put our answer in there. So on this one, notice that when I click the parabola, it's got 2 little points on it. So when I click the parabola, I'm going to identify where the vertex is first. Well, you guys told me it was over 4 and down 6. So there's the vertex. Now I've got to pick a second point. Well, normally I would go over 1 and up 1, but because A is 3, I'm going over 1 and up 3. So my second point is going to be there, over 1 and up 3, or over 2 and up 12, right? I could have done that one also, right? I could take that point and I could stretch it up to where it goes over 2 and up 12 from 6 would be at 6. Either way, it's going to be same looking graph, okay? And then I would check the answer and that would be right. Now this is a new problem here, so it's not, I got to pick new values of A, H, and K, but for the ones that we wrote down, that's how I graph that parabola. Does that make sense? Everybody give me 1 to 5 on that. Okay, good. I really like this technique because you have to identify where the vertex is going to be, and then you use A to just drag out a second point, a dilated point. And I think it's a really efficient way of graphing them, and it forces you to understand what A means. Okay, I'm going to quit talking then. You don't have a ton of time, but you have some time, so have at it. I'm here to answer questions. Go.